plug in the 1. Okay, you plug in 1 here, you get e squared. So that's our point. Then your slope, make sure you do need the chain rule here. So when you take the derivative of e to the 2x, it's e to the 2x times 2. Then plug in your 1. This is your slope. And then y minus y1, slope, x minus x1. Good on part A? Okay, part B, for area, you only want to integrate under the function. Okay, and then we're integrating from where to where?
0 to 1.
Okay, 0 to 1. And then the top of my function is e to the 2x. The bottom of the function would just be the x-axis. So that'd be like e to the 2x minus 0, but you don't have to write that, yeah? Okay, did you do chain rule? Or I'm sorry, not chain rule, u sub?
No, I will.
Okay, so do u sub. What is your u going to be?
2x.
Okay, 2x. So du is going to be?
2 dx.
Which means that dx is du
Over 2.
over 2. What else do you have to remember to change? Endpoints, very good. So it'll be integral e to the u du. And then instead of putting my over 2 in the integral, I'm going to put a 1/2 in the front. Top endpoint was a 1. Plug into the 2x. Now it's a 2. Plug in 0. E to 0 times 2 is going to be still 0. And then what's the antiderivative of e to the u?
E to the u.
Still e to the u. Remember, if you change your endpoints, you don't go back to the old endpoints. So it'd be e squared for the top one, and then e to the 0 for the bottom one. What is e to the 0 the same as? 1. Is that the answer?
No.
What did I forget?
The half, yeah.
Good. Yep. All right, part C. Actually, yeah, never mind. C is good. Okay, it says region R forms the base of a solid whose cross sections perpendicular to the y-axis are squares. Write but do not evaluate an expression involving one or more integrals is your hint that it's probably one of those ones that you're going to have to break up. Whenever it says one or more, you know something's weird. Okay, one or more integrals, that gives the volume. Okay, so let's go step by step. If it is a square, how do you find the area of a square?
B squared.
Okay, a equals b squared. And if I'm perpendicular to the y-axis, which way are they running?
Right to left to B.
Sideways.
Yeah.
Yeah? Okay, so I'm going to come up to my picture here, and I'm going to draw in my base. Now, if I draw in my base this way, what two things am I touching? X equals
1.
1 and 0, yeah? What about if I draw my base up here? Am I touching the same two things?
No.
No, I'm touching two different
How do you
things.
know where to put your base?
Where it switches. So at what point does the side of my curve switch?
Right there where 1 is.
At 1. And notice they even labeled it for you, so that's another thing where it's kind of like, why would they label that? So I'm going to break this up like that at 1. Now, the base for the top part, what's my right line? X equals 1 minus. Can I use e to the 2x to describe this line if we're doing this dy?
Yeah. No, you have to change
No.
it to y equals.
Yep, so if it's y equals e to the 2x, how am I going to solve for x?
L on both sides.
Okay, so I have ln y, and then my e's gone, now it's a 2x,
Divide by 2.
then x. I'm going to just put a 1/2 in the front, but that's the same. So this line over here is going to be 1 minus 1/2 ln y. So far, so good? Okay. Now, when I set up my integrals, remember, these are my bases, and my area for a square is just base squared. What else do I have to remember? I'm using, instead of x values as my endpoints, I'm going to use
Y to dy.
y values. So, come down here to the part that we were working on. My first integral is going to be volume equals the integral from, what is this bottom part that I'm shading?
0 to 1.
0 to 1 are my y values. And then my base was 1 squared dy plus. Then for my top part, what are my y values?
1 till e squared.
1 to e squared. And then what's my right minus left?
1 minus half ln. Okay, could you?
And then squared dy. Yes?
Okay, can you explain how you got all of that?
Yeah? Okay, so it's my area, if it's a square, it's going to be the base squared.
Yeah.
So at the top, I went 0 to 1 with 1 squared. Because also notice, think about, is this width changing?
Oh, I thought you just did that base because you just wanted to give an example.
Well, so the problem is that your base is bordered by two different things. On the bottom, it's 0 and 1, but then when you get past this line, it's 1 and the curvy line. Okay?
Do it twice, basically.
Yeah, so you have to break it up into two pieces, kind of like the one we did in class today, where it was revolving and you had to set up separate ones. Questions about that are good?
Good.
Okay, go down to part D. Region R is now revolved around the line x equals 3, right? But do not evaluate an integral expression for the volume of the solid. So what are we revolving around? X equals 3. Okay, so I'm going to kind of redraw my picture down here because I scribbled all over the top one. So we have x equals 1 right here. X equals 3 would be way over here. And then we have our e to the x curve that curves up like that. Remember that this is y equals 1. Remember that this is 1 comma e squared. Now, let's also label our line. Are we going to do this dx or dy? dy, which means our equation can't be in y equals. We need to continue to use the x equals 1/2 ln of y for this.
How do you know it's revolve around y?
Because your line is up and down. If you're revolving around the y-axis or a line that looks like the y-axis, it's going to be dy. Versus if you're revolving around the x-axis or any other flat line like the x-axis, you're going to do dx. Okay? So here's my line. Question, what is my inside r, my little r?
It's the shortest one.
Yep, here to here. Good. So 1r. What about my further away r? Is it the same the whole time? Or, oops, I should have drawn a little r. Okay, what about my capital R though? Is it the same the whole time or does it break up?
Breaks up.
It breaks up at where?
From 3.
At 1. Yeah? So for my capital R here, it goes that far, but then above the line, my capital R goes here.
I thought it would be only one capital R.
Normally there is, but because this, and this is how you know. Think about if I want to draw my line from this to the curve, if I do it up here, I'm touching the line and the curve. But if I do it down here, I'm touching the line and then the y-axis. Does that make sense? So again, we're going to have to do, instead of only one washer, we're going to have to do 2, and our breakup point is going to be around 1. Now, keep in mind, all of the questions they put on the AP test aren't usually going to be this hard. Okay?
Watch that 1 year be this year.
But we're practicing anyway, just in case. Okay, so let's do this bottom chunk first.
Y equals pi from 0 to
1, because we're just doing the bottom half, and then what's my capital R squared? Right minus left.
right. Okay, so
3 minus 0, so that'd just be 3 squared, minus, what's my inside function?
minus 3.
3 minus
1.
1 is 2 squared. dy plus
dy plus
pi integral. Now we're doing the other chunk. So now we're above the line from 1 to where?
1 to 3.
E squared.
Yeah. Wait, so are you doing your big R's first?
Uh-huh.
Okay.
And then what's my big R for the top part? From 3 until touching where?
The x squared.
The x equals 1/2 ln y. Yeah? So it'd be 3 minus 1/2 ln y squared, and then plus, and then what's my little r still? 3 minus 1 is still 2 squared dy. Does that make sense?
Where'd you get the 2 squared from? Okay.
Because the middle r didn't change.
So
The only thing that changed was the big R.
What did you put a plus?
Because I'm doing this volume plus that volume.
Plus 2.
Oh, oops, that should have been a minus, thank you.
Okay. And there's no integral after that? Like, it's not minus integral?
Because you're doing this volume plus that volume, but you're doing it in chunks. Kind of like when you break up an area into two pieces, it'd be the same thing as that. Okay, now for fun, I'll just let you know that I added that part D. That was never actually on the AP test. Okay, so don't worry. They probably won't do that to you. Okay, next one. Alright, let's see what we remember about a little bit of particle motion.
No, I don't like this.
Yes, you like it. You love it. Okay, we have a particle. It gives you its position. Notice it reminds you that time has to be bigger than 0. Part A says, is particle X moving towards the left or towards the right at time 1? Do we plug into position?
Yes.
No, wrong. You want to know if it's moving to the left.
So don't you need position and velocity?
You need velocity. Now notice it doesn't say towards the origin. It just says, is it moving towards the left or is it moving towards the right? So this is asking you, velocity, is it positive or negative? Yeah? Okay, now most of the time they do now ask, is it moving towards or away from the origin? But this question's even easier than that. It's just saying, is it going left or is it going right? So find velocity.
So V of t equals prime.
Okay, and remember it's good to list that out. So velocity is x prime, then we're going to take it. What is the derivative of that?
15t squared minus 18t.
What happened to the 7?
Bye-bye.
Okay, plugging in what?
0.
Nope,
No.
1. So 15 times 1 is still 15, minus 18 times 1 is 18. Overall, what's your number?
Negative 3. So
Okay, what did I do wrong?
oh, you forgot to put x of 1.
Yep, can't do this. You have to put v of 1, or you could put x prime of 1, but once you start plugging in numbers, you want to make that change on your paper. Okay, so this came out to be negative. Which way is our particle moving?
To the left.
Okay, v of 1 less than 0, therefore particle's moving left. Particle moving left. Okay? Now, does that necessarily mean it's moving towards the origin? Just because it's moving left?
You don't know?
No, you would also have to check what else? The position. So go ahead and just plug in 1 here real quick for fun, because that's what they ask more these days.
5 minus 9 is negative 4.
Negative 4 plus 7?
Positive.
Positive. So if your position is positive, but you're moving to the left, are you moving towards or away?
No.
Towards. Think about it. Here's 0. You're on the right, but you're coming left.
Yeah.
So also keep in mind, if they're the same sign, you're going away. If they're opposite signs, you're going towards. Okay? But you can always draw a picture. Okay, so part B. When is the particle farthest to the left? They're asking you for a max or a min?
Min.
Minimum. Okay, so we already found the velocity here. We just need to set it equal to what?
0.
Okay, so I can take out a 3
And a third tag.
and a t. And then from there, what's left over here?
A 5t minus 6. So t can equal 0 and t can equal 6.
Okay, set up your line test. When you do your line test, remember time starts at 0, so I don't have to consider any numbers to the left of 0. Oops, that should be 6 over 5, yeah? So 6/5 is our number. Is that bigger or smaller than 1? A little bit bigger, so let's pick 1. So if I plug in a 1 here, 3 times 1 is positive. What is 5 times 1?
Negative.
So 5 minus 6 is negative. So overall, negative here. What about if I pick like 2?
Okay. Positive.
Positive here. 10 minus 6 is positive. Multiply 2 positives. There you go. That means that my velocity changed sign from negative to positive. What did my position or my particle do? It went from decreasing to increasing. So is that a minimum?
Yes.
Now, how do we know that it's the absolute minimum? Because it's the only one. Very good. So you would say you have a relative minimum at t equals 6 over 5 because v of t changes negative to positive. Also, it's the absolute minimum because it's the only one.
So if we don't say it's the absolute minimum, do we get punched off?
I don't know. Because it's the only relative.
I feel like you would remember that when you're like stressed on time.
Yeah. And that's where, too, you also want to remember that, like, the number of times that a person has gotten a perfect score on the AP test is, like, literally twice in, like, the 60 years that they've been giving it. So it's not like the SAT where, like, people get every question right. The AP test is very much, like, you're going to get some of them. Sometimes they're strict. Sometimes they're not as strict. Okay, next one. A second particle y moves along the positive y-axis so that its position at any time is given by that. At any time, the origin and the positions of the particles x and y are the vertices of a triangle in the first quadrant. Okay, let's stop, draw a picture of that for me, please. What is particle x moving on? What does it say?
Y-axis.
Okay, let's go back to particle x.
Oh, positive y-axis.
So x is on the
On the right side.
x-axis and y is on the y-axis. Okay, so let's draw that first. Also, it does say that they're both positive. So I'm going to draw x and y there. Then look what it says right here. The origin and the positions of the particles are vertices of a triangle. Draw the triangle. There's your triangle. Find the rate of change of the area of the triangle. What are they asking you to find? dA dt. Okay, then it says at time t equals 1. So I'm going to skip my given and go to my when. What's my when?
1 times.
When time is 1. And then my equation, how do we find the area of a triangle? 1/2 base times height. How long is the base?
X.
X. How long is the height?
Y.
Y. So 1/2 x times y. So far, so good? Okay, now let's go back to our given. What is the change for dx dt? Okay, think about that, what that means. dx dt is how fast x is changing. What did we find earlier that is the same as that? V, which is really x prime. So dx dt is how fast the position is changing. We already have a word for that. That's velocity. Now, the other thing you can think about to kind of connect those dots is dx dt is the derivative of x. What's the derivative of x?
Velocity.
X prime. Yeah, which is velocity. So I'm going to put down here dx dt equals 15t squared minus 18t. Not super useful right now, okay, but that's what we have so far for dx dt. Now let's also talk about dy dt. Look what they gave us. They said a second particle y, blah, blah, blah. Its position is given by. This is position. How could I find how fast that particle is moving if they gave us the position?
Derivative.
Take the derivative. Very good. So take the derivative of this to find y prime. It's linear, so what's the derivative? 7. So they're making you find them yourself, but you can still do it. Okay? Now, let's come down to our equation and take the derivative. You can leave the 1/2 here. I'm going to multiply it up by the a like I always do, but you don't have to do that. You can do product rule with the 1/2 in there. So I have 2a x times y. What rule are we going to need on the xy side? Product rule. So my u is going to be x, my v is going to be y. When I take the derivatives of those, what do I need to remember? What's the derivative of x?
1.
Nope.
dx.
Dx dt. And what's the derivative of y?
dy.
Dy dt.
Well, I thought you said if you want to take the derivative of x, it would be...
Normally it is 1 if you're doing the derivative with respect to x. But if this is a t down here, do x and t match? No. Now remember, like when we do all the dy dx stuff on the bottom, that's when you don't have to have an extra dx dx because it doesn't make sense because the letters already match. But if it's with respect to time, the only thing that wouldn't leave a weird ddt is if it was also time. If those letters match, that's when you don't have it. Okay? So from here, what's the derivative of 2a? 2 dA dt. And then on the other side, we're going to write out our product rule. X dy dt. And then y dx dt. So far, so good? Okay, we're plugging stuff in. 2 dAdt, that's our unknown. What is my x value, or do I not know it yet? I don't know it yet, but what do I know? What's my when? Time is 1. And didn't we find that earlier? What did we get? Let's go back and see. So we're plugging in 1. What is it? 3. So we'd plug in 1 right here. 5 minus 9 is -4, plus 7 is 3. So my x, which is the position of particle x, is 3. We got that by plugging in. What's my dy dt? 7 plus. How am I going to find the position for particle y at 1? You're going to have to go back and plug it in. Yep. So I'm plugging in, remember, time is 1 up here. So 7 times 1 is 7, plus 3 is 10. And then my dx dt, I have this equation, but what do I know about time?
1.
It's 1. So 15 minus 18 is -3. Now, can I leave it like that? I have to get rid of that too. But then if you want to leave it, you totally can. So I'm going to put dAdt equals, that'd be 21 minus 30 divided by 2. Okay? Now, just quick question here. Does that come out positive or negative?
Negative.
Would come out negative. What's happening to the area of the triangle then?
Shrinking.
It's decreasing at that moment. Now, does that mean it's always decreasing? No, but at that particular time when we plugged everything in, it came out less than 0. Okay? Good job. Next one. All right, equation of a tangent line. You can do that one. Go ahead and do A, B, and whatever you can on C. And you can work together if you want. And notice they're already giving you the point right off the bat, 1, 2. Got 15 minutes left. You can do it. 15 minutes. You can throw this away first.
That's okay, I can do it.
Oh no, I'd love to help.
Yeah.
Okay, and then you plug it in your point up here. So you know x is a 1 now. So you don't have to take the derivative, you're just plugging into that because it's already d by dx. Yeah? Now y'all remember your notation when you're finding the slope. You should be putting dy dx line 1 comma 2 before you plug in, right?
What if you forget to put that and they still give you points?
Don't know. Maybe, maybe not. It depends if they give you a point just for that or if they give you the point for the equation. So if they give you the point for the equation and you have the equation right, it doesn't matter if you labeled it or not. Does that make sense? So what is 1 minus 2 over 1? Or 1 minus 2? Negative 1 multiplied by 2 minus 1 is positive 1. So overall your slope is negative 1. So it'd be 1 minus 2, or I'm sorry, y minus 2 equals negative 1, x minus 1. What do we plug it in? What's our decimal? Okay, 1.2 plugged in there, y minus 2 equals. What is 1.2 minus 1? 0.2. And then if you want to be extra lazy, just cross that out, plus 2, and you're done.
Is the answer negative 2.2 though?
It'd be negative, nope. Negative 0.2 plus 2, what would that be? Positive 1.8, if you want to go that far. But remember, if you're not confident with it, just stop there. Okay, part B. This is the weird question that's really easy. Read through it, see if you remember how to do it. Super, super easy if you can understand what they're asking you to do. Anybody remember? What's C?
It goes on
1.
It is 1. Okay, why is it 1, Helen? That's correct.
You plug it in, just like find a value that will subtract 1 to equal y.
Yeah. So it's saying if you want a horizontal asymptote, remember that horizontal means that you have a dy dx equal to 0, right? So they're basically saying what is going to make it equal to 0. Well, if I plug in a 1 right there, 1 minus 1 will 0 it out. Okay? So remember, that question's really, really easy. You just have to kind of remember, horizontal is a 0 slope. What will make it 0 if C is a 1? Okay, last part. What will our separation look like? We know we want a particular solution. Remember, you have to separate first.
1 over 1 minus 1 dy equals 1 minus all that stuff.
And then dx, right? So 1 over y minus 1 goes on the left. 1 minus 2 over x squared is going to stay on the right. Which side is going to need u sub and which side is going to need a rewrite?
U sub on the y.
Okay, u sub on the y side and a rewrite on the left side. Okay, let's do the u sub side first. So u is y minus 1. Du is what then? 1 dy, which means that dy and du are the same. That means that you're not going to have any weird extra numbers in the front. So integral of 1 over u is what?
1 over u ln u, or ln 1 minus 1.
ln, and then I'm going to put my y minus 1 back in. Remember, you should also have absolute value bars at that point. Okay, other side. Try to do your rewrite on your own real quick. The 1 obviously is going to stay the same. It's the 2 over x squared that you're going to have to change. How will we change that? Yep, move it to the top, and what's going to happen?
1 minus 2x negative 2.
Good. So your x squared is going to have to move up. It's going to turn to a minus 2. Okay, do the antiderivative. Don't forget your plus c. Your letter on that side is x, so what's the integral of 1?
1x minus,
Okay, 1x. I'm just going to put x there, but 1x is fine. Then I have to add 1 here. It's a negative 2. What's negative 2 plus 1? Negative 1. Then I have to divide by negative 1 on the negative 2.
positive 2.
So it switches to a plus 2. Now, you can leave it like that, but I'm going to rewrite it one more time. And I'm going to make it x plus 2 over x. So far, so good? Any questions about that so far?
How come you don't have the integral sign in front of 1 minus?
I should have had it here, and then when I do the rule, I should have lost it. So you're right.
Not the first one.
Yep, I should have. So when you do an integral on one side, make sure that is important. Maybe draw them at the same time so you don't forget. And then once you do the antiderivative, obviously it goes away. Okay, what's the next step?
E both sides.
E and E. E and ln cross out. Y minus 1 equals
Go to the top.
C e to the x plus 2 over x. Then take your minus 1 across to the other side. Make it a plus 1. Make sure it's not part of the exponent because it was added after that step. And then go back and find your C. What's your initial condition?
F of 1 equals 2.
Okay, f of 1 equals 2. So I'll give you a minute. See if you can unscramble all that. Okay, what might you do first?
Plug in the numbers.
Okay, plug in the numbers. So then I have 2 equals CE. If this is 1 plus 2 over 1, that's 1 plus 2, which is just 3. We want to solve for C. What do we do next? Minus the 1, good. So 2 minus 1 is a 1 equals CE to the 3. Then what could you do next? Divide the e to the 3 on the bottom. Now, your other option for that, if e to the 3 is on the bottom, how else could you call it? E to the negative 3. But remember, it doesn't matter. If you like it better like this, leave it. If you like it better like that, leave it. Doesn't matter. So my final solution, or my particular, would be 1 over e cubed. That's how I'm going to leave it. E to the x plus 2 over x plus 1. And remember, this is your general solution, and this is your particular solution. And remember, you get tons of points along the way. So if you don't get to the very end, at least do whatever you can do. Okay? All right, we have time for probably one more. Look at the last two. Which one looks like we need to review it more? The very next one or the last one?
That's from my son. I don't know. Could you the first? Yeah.
Okay, let's do it. Okay, Ruth rode her bicycle on a straight trail. She recorded her velocity in miles per hour. Select the values of t over the interval 0 to 2.4 hours as shown in the table. For 0 to 2.4, velocity is greater than 0. Did Ruth ever turn around? If her velocity was always positive, she was always going forward. So we don't know if that's going to matter, but we'll see. Okay, part A. Use the data in the table to estimate Ruth's acceleration at 1.4. What's in the table right here?
Velocity.
We want acceleration. What's the relationship? Okay, acceleration's the derivative, but we don't have an equation. So we can't take the derivative, but we can do the AROC. Where are we going to do AROC for 1.4 to be between? Good. So I'm going to write average rate of change, 1.2 to 1.6. Can I put F of 1.6? No, V of 1.6. V of 1.2. 1.6 minus 1.2. Okay? V of 1.6 is what? Okay, 16.3 minus V of 1.2 is 17.2. 1.6 minus that is 0.4. Okay, what am I missing? Because I don't have to finish the arithmetic. Yep, what does it say right here? Indicate units of measure. So if velocity is in miles per hour.
Miles per hour squared.
Miles per hour squared. Oops, I put milers per hour. Ignore. Okay, go to part B. Using correct units, interpret the meaning of the integral from 0 to 2.4 in the context of the problem. Okay, then they're going to have us find it using a midpoint Riemann sum with 3 subintervals. Okay, do the meaning first. So try to write something down, kind of like we did in class, and then we'll see if you got it or if you're missing something. And remember, you want to have your units, you want to have your noun, and you want to make sure you have your time, all of those 3 things. So write it down and we'll check it. Also remember, when you integrate a rate, you lose the per hour on the bottom. So if this is in miles per hour, what does it represent?
Represents the miles that Ruth.
Okay. Miles, Ruth, what?
Bicycles from 0 to 2.4.
Rode her bike from 0 to 2.4 hours. Now, you also could have said it's the change in her position from 0 to 2.4 in miles. You could have said it's the distance that she rode. That's fine. Now, the one thing about if you use the word distance, remember that distance really needs absolute value bars unless it's always positive. Did they tell you it's always positive? Yeah, right here. So in that case, it kind of saves the day. If you use the word distance, you're okay. But if any of the numbers were negative, distance would not have worked. If distance doesn't work, remember the word you can use is displacement. Do you remember that? So I'm going to put, or you could put Ruth's displacement. Okay? All right, set up the midpoint sum. Let's see if you remember that. In miles. This would be another way to write it. over 0 to 2.4. But you would not obviously do both. You'd pick one. Okay, midpoint sum. What do you have to do in the middle? Do you remember?
You would find the difference between two.
You have to skip one. Is your delta x the same for all of the ones as you're skipping? Okay, how long is this one? 0.8, because remember we're skipping one. Then from 0.8 to 1.6, how far is that? 0.8. What about from 0.8 to 2.4? I think I said that wrong, but you get the idea. Okay, and then which y values am I going to use if I'm doing a midpoint? Middle, middle, middle. But remember, if they're all the same, you can pull that 0.8 out to the front. So it would be 0.8 in the front, and then it'd be 11.8 plus 17.2 plus, and then 16.8. Good? All right, next one. For 0 to 2.4, Ruth's velocity can be modeled by, then they give you the function. According to the model, what was Ruth's average velocity during the time interval? Not going to make you get out a calculator, but write down what you would do. You have her g of t, which it says is her velocity, and they ask you for her average velocity. Is this average rate of change? No. What is it instead?
So 1 minus.
Average y value. And remember, you know it's the average y value because this is velocity and you want average velocity. So it would be 1 over what?
2.4 integral from 0 to 2.4 gt dt.
Okay, good. 0 to 2.4, and then you'd put your gt in there. Now remember, you would not do that integral by hand. You would use your calculator and then divide it by this is a 2.4. Okay? One other thing on the AP test, sometimes in the multiple choice, they'll write it like this. Do y'all see that that's the same?
Yeah.
Okay, so if you see on like the multiple choice, yeah, sometimes they'll write it like that and they'll ask you like, what does this represent? It's still average value, they're just writing it kind of weird. Instead of putting it in the front, they're dividing it, okay? Alright, last part. Part D, according to the model in part C, is Ruth's speed increasing or decreasing at 1.3? How do you find if her speed is increasing or decreasing?
Wouldn't he put it in the calculator?
Yeah, okay, pretend it's in the calculator.
So what you would put 1.3 on t. So all you.
Okay, so I'd find g of 1.3.
Yeah.
Okay.
And you do it from 0 to 2.4.
Okay, now real quick, just we can do this easy. 24 times 1.3, and then plus 5 sine 6 times 1.3 over 1.3 plus 0.7. Just think about the sign. Okay, what is 24 times 1.3?
Positive.
Like 24-ish, right? And then I'm adding 5 more.
More positives.
Okay, more positives, and then I'm dividing by more positives.
Overall positive.
Overall positive. Now, sine, the biggest it gets is 1, smallest it gets is -1. So even though sine could be negative, it could not be negative enough to make the whole thing negative. So, because my g, remember this is velocity, because my g is positive, does that mean her speed is increasing? No. What else would you need to find? In the calculator. Not position. Acceleration. You would find g prime of 1.3. And let's pretend that that comes out positive. Okay, I'm going to just put we guessed. Okay, because none of us have calculators out. Okay, if it also came out positive, what would your conclusion be? Speed increasing or decreasing? What if they came out opposite signs? Speed would be decreasing. Okay? And then it says give a reason, so we're going to put therefore speed increasing.
From 0, 8. No. From
Because
g prime of 1.3 and g of 1.3 are similar.
have same sign. And make sure, don't say like are similar or they match. Don't put any weird non-math terms in there. They have the same sign. Or you could put they're both negative if you like, but don't put any other like weird verbiage. Okay? Good job. Great job. You have your purple sheets?